every design principle you've ever learned, decoupling, single responsibility, clean abstractions, they're all wearing different disguises, but underneath they share one single heartbeat. And that heartbeat is this: good design is easier to change than bad design. Software engineers call it ETC, easier to change, and it's the most powerful idea nobody talks about enough. Think about your last project. How much time did you spend building features versus changing them later? If you're like most engineers, change consumed more time than creation, way more. Studies consistently show that software maintenance consumes 60 to 80% of total project cost. And what is maintenance really? It's change. So here's the shift. Instead of asking, is this design clean? Ask, is this design easy to change? Because change is inevitable. New requirements arrive, old assumptions break, budgets shrink, teams reorganize. The code that survives is the code that bends without breaking. Let's see why. Take decoupling, keeping modules independent of each other. Why do we decouple? Because when you change one module, you don't want a chain reaction of breakage in 5 others. That's ETC in action. Decoupling makes change easier by localizing its impact. Single responsibility? Same story. One class does one thing, so when that one thing changes, you touch one place. Named abstractions? They give you a stable handle to grab, even when the implementation underneath evolves. Every principle you've studied, DRY, YAGNI, separation of concerns, they all trace back to the same root: make change cheaper. When you see them all as expressions of one idea, something clicks. You stop memorizing rules and start making decisions with a compass instead of a checklist. Here's the practical test. When you're choosing between 2 approaches, ask yourself, which one leaves more options open for future me? You won't always know which change is coming next. That's fine. ETC isn't about predicting the future. It's about keeping the blast radius small when change inevitably arrives. A well-designed system isolates change. When a new requirement lands, it touches one module, one file, one team, not the entire codebase. Think of it like building architecture. A good floor plan lets you reconfigure rooms without tearing down load-bearing walls. A bad floor plan forces you to demolish everything just to add a window. Now, here's where many engineers stumble. They feel ETC intuitively but never apply it explicitly. Feeling it isn't enough. You need to make it a conscious decision at every fork in the road. Say it out loud in your design reviews. Which path makes future changes easier? Let's look at a concrete example. Imagine a hard-coded API endpoint buried deep in your application. Every environment, dev, staging, production, points to that same URL. To change it, you'd need to recompile and redeploy. Want to point staging at a different service? Too bad, that URL is baked in. Want to test against a mock server? Edit, compile, deploy, wait. Every single time. That's rigid. That's the opposite of ETC. Now extract that URL into configuration. Suddenly, you can redirect traffic without touching code or shipping a new build. One small change to the design, and the cost of every future change just dropped dramatically. That's the power of ETC. Small design choices compound over time. Over months and years, the gap between adaptable code and rigid code becomes a canyon. One team ships features, the other fights fires. Here are 3 things you can do today, starting with your very next pull request. First, in your next design review, force every person to answer one question: what becomes harder later if we choose this path? Second, find one rigid constant in your codebase, a hard-coded path, a magic number, an inflexible endpoint, and make it configurable. Third, choose names and module boundaries that align with the directions your system is likely to evolve. Names matter. Boundaries matter. They're the seams where future change will happen. When you name a module after what it does rather than how it works, you give yourself permission to change the how without renaming everything. Because here's the deeper truth. Changeability is the meta quality that preserves every other quality over time. Your code can be fast, secure, elegant, but if it can't adapt, all those qualities erode when the world shifts. The best engineers don't just write code for today, they write code that's ready for tomorrow, even when they don't know what tomorrow looks like. So the next time you're at a design crossroads, remember the one principle that rules them all. Good design is easier to change than bad design. Make change your ally, not your enemy. Start today. Your future self and your team will thank you.